with us today. And what does it mean to fix or rehabilitate a sewer when it's not in the middle of the street? That's what we'll talk about today. But firstly, just introduction. My name is David Scott. I'm a senior civil engineer and project manager with Tetra Tech, and I specialize in lakeline construction and condition assessment. And originally from Belfast, been in the Pacific Northwest since 2002. But if you hear a few funny vowels, that's the reason. And I'm joined today by Kim Staheli. And Kim, if you want to say a few words of introduction for yourself there.
I'm sure. My name is Kimberly Staheli. I am the president and founder of Staheli Trenchless, and we specialize in all different trenchless techniques. We're a very focused firm on trenchless technology. And with that, I'll pass it back to you, David.
Yeah, thanks, Kim. Well, just an overview of what we'll cover in our time together. I'll give an overview of the project and the team. I'll touch on the alternatives analysis, but really the bulk of our time will be spent on the design phase. I'll cover some of the access and staging challenges as well as the permitting. And then Kim is going to do a deeper dive on the more technical aspects of the CIPP and the rehab. But, you know, starting at the 30,000 foot level and kind of narrowing all the way down to the project site and the design. Big picture, King County Wastewater Treatment Division is the client. They serve about 1.5 million people, both with treatment plants and also with trunk conveyance, about 350 miles of pipe. And our project is looking at about 3 to 4 of those miles. And if we zoom a little bit closer in, so we've got Seattle here. I'm assuming you can all see my cursor. Let me know if that's not the case. But we've got Seattle here, Lake Washington, Bellevue. If we zoom in a little bit closer, we've got Mercer Island, which is in the middle of Lake Washington, and then the southwest corner of Bellevue. The conveyance system that serves the shaded areas here starts at the North Mercer pump station and then hugs the shoreline. It's actually a lake line. It crosses the I-90 bridge and also the east channel of Lake Washington. Then when we get to Bellevue, there's an interceptor, the Enatai Interceptor, hugs the shoreline and relays flow to the Swaylock and pump station. And then it gets relayed further towards the treatment plant from there. So that's the existing system. In terms of our project, so this is a kind of similar view. You've got the North Mercer pump station at the upper left and Swaylock at the lower right. A couple of things to note. The new alignment is upland. So we've pulled most of the conveyance out of the lake along Mercer Island. Now we will have a new crossing of the East Channel. We'll have a new horizontally directional drilled siphon that goes from the shoreline over to the Swaylock and pump station, kind of cuts underneath the hillside here. And we will be rehabilitating the existing Enatai Interceptor. And really that's where we're focusing our attention today. So looking at a little bit more detail at the interceptor. So aerial view here, this is the same kind of shoreline. This is the Swaylock and pump station at the upper right. So about 4,000 feet, 27-inch concrete pipe installed in the 60s. And the first half was lined in the early 90s, but not without issue and some defects. And Kim will talk more about that in the second half of the presentation. But that's kind of the existing condition. And then what we're doing for design, so work at the swim beach with some replacement and slip lining. spot repair on the existing lining in front of the Enatai homes, with 35 homes here with direct connections to the trunk sewer. And then new lining for the remainder of the pipe through, this is Mercer Slough, and adjacent to this bike trail. So we'll talk a little bit about staging and access challenges, but having given you the big picture, I'll park that for a minute and just an introduction to the wider team. We mentioned King County, they're the client. Tetra Tech is providing the PM and coordinating the east side design. Staheli Trenchless is providing the trenchless support and expertise for the HDD and the rehab along the Enatai Interceptor. And then Jacobs Engineering is providing the design lead and also leading the design on the Mercer Island side of things. We do have a fairly extensive sub-consultant team. We've got easement support, environmental permitting, as we work through these critical areas. And then I'll touch on the alternatives analysis, which is a really good foundation for the design. We looked at a lot of alternatives, channel crossing options, construction methods. And in terms of the preferred alternative for the Enatai Interceptor, we are retaining its use. It allows service for the existing local city Bellevue Lake line, as well as the homes along the shoreline that we looked at. In addition to that, it will continue to receive the low flows from Mercer Island, but the higher flows will be diverted to the new HDD, the 32-inch that goes to Swaylock. And really, capacity is the driver for this project. The existing capacity of the system is about 10 MGD, and this project will increase the overall capacity to 16 MGD. And that will serve for the 50 years through about 2060. So, you know, the other thing that I'll say about the alternatives analysis, when working in water or through critical areas, it provides a really good documentation of why we're looking at what we're looking at, so that the preferred alternative doesn't meet a hard stop as soon as it hits the permitting process. Typically, cost is not an acceptable rationale for selecting an alternative in those critical areas. So the alternatives analysis did provide that foundation. We were able to successfully push through into the design for each of the different areas. Okay, so I'll jump back to the access and staging for the different sites. So here's that sort of aerial image. And really just to break things up, we'll look at the swim beach. There's a public park there, the shoreline homes, the wetlands or shoreline here, and then the bike trail. And just one thing about the bike trail, that's part of a much wider system that connects all points east through Bellevue to as far as Seattle. So it's a heavily used commuter route that's right beside the freeway in this location. So let's take a look at the swim beach. So the work here is we've got pipe replacement and slip lining. We will have flow diversions, and access is both from land and in the water. The photograph on the upper right is looking back towards the beach. It is a public park. It's really heavily used in the summer. This was, I think, the turn of the year when I took this photograph. And then the lower right is a plan of the beach. You can see that the interceptor is partially in the water, and then there's a slip lining portion across here. Three things that I'll say here. Firstly, because we were able to offload the flow, some of the flow, the high flows, we can actually use a smaller diameter pipe for just this particular section. And that allowed us to implement slip lining rather than excavate close to the high voltage underground electrical cables that run underwater out to serve Mercer Island. The flow diversions that will apply here, so secondly, we'll use the new horizontal directional drilled siphon as part of that flow diversion. And consequently, this element of the work will be done last. So it's a 3-year construction schedule. This will be the final element. And then finally, while we have access from the shore for the temporary park closure, we'll also provide a containment cell so that we can work in the dry in this area below ordinary high water mark. And what do we mean by a containment cell? Well, schematic here on the left and a sort of picture of a typical installation on the right. We'll have a dewatered work zone. We've got super sacks or bulk bags, sometimes they're called that, and sheeting that allows us to get a dry or at least a semi-dry work zone for which we can do the open cut. And then moving further around the shore, so this is in front of the shoreline homes. So this is for liner repair. The access is from the lake only through maintenance holes or manholes underneath the docks. And the county has obtained easements for this as well. Picture in the upper right, that's from another project we led the design on, just illustrating barge access close to the shore. One thing that we frequently observe is there's very limited access from the roadway to the shoreline through private property, and that has other complications as well. So access will be via the barge. And what we're trying to get access to are angle structures along here. This is where most of the defects have occurred, or all the defects have occurred. And an angle structure is pretty much what it sounds like. It's a structure at the angle. It doesn't have a riser like a manhole riser. Instead, it has a concrete lift slab that's sealed and bolted down. And they're buried in the lake and underwater. And working with GAME, we were able to find a way to access these from the maintenance holes. And as a result, that was a big cost saving in terms of access. And then moving on to the wetlands, or the shoreline area. So this is for the new CIPP. We've got land access and in water access. We'll have containment cells. The photo in the upper right here is of one of the angle structures, and the photograph in the bottom right is for an example of swamp mats that we'll use to provide a working corridor. I suppose this is kind of a little bit of a Where's Waldo moment. Angle structure 9 is kind of in there. You might be able to see bubbles. This was from a dive inspection to verify the location and also the configuration of the angle structure. And it's maybe illustrative of the shallow draft work boats that we can get in to do some of the work here, but this is shallower than along beside the shoreline homes. And then the fourth area is the bike trail. And so that again is for the CIPP, the new CIPP. And there's access strategies and diversions we'll talk about. The photograph in the upper right is illustrative of the limited width that we have. This is the west end of the project. It's about 12 and a half feet. So we can get equipment in there, but it's somewhat constrained. And as I said, this is a heavily used commuter route. So not only are we looking to minimize impacts environmentally, but also the people or human impact as well. A couple of strategies that we've used. So the photograph in the lower right, we're limiting access where we can. That photograph is of a trail in a part, runs right through the wetlands. It's got soft foundation material. We don't want to put heavy equipment on it. And we can get access without working on that central part. And then staging off the trail so that the majority of the pedestrians and trail users can continue to use the trail during the construction period. Now, there will be some impact and diversions. We tried to minimize that with using short delays, like 5-10 minutes to get equipment in. When we're doing trail restoration, we'll be able to use walk-arounds. So having cyclists dismount, walk around the area, but continue to use that main corridor and minimize the use of the wider neighborhood diversion, which includes hills, and not everybody has power assist bikes just yet. I've got one other photograph on the bike trail. So this is a fisheye photograph. So the geometry is not kind of CAD standard, but it's illustrative of the bike trail as it runs parallel to the Mercer Slough. You can kind of just about see a maintenance hole sticking up above the water line. And there's an angle structure here that's buried in the slough on this side of the trail bridge. So kind of illustrating that, you know, even when we've got kind of wider open space, we've got slopes and we've got the wetlands to contend with. So those are some of the aerial or geographical physical constraints that we have on the site. Before I hand over to Kim, I just want to touch on the sort of the permitting and the other larger constraints that impact how we've planned the work and permitted the work. We have done an extensive permitting exercise to get the approvals that we need. So that's federal, state, and local. And I've listed 3 other kind of big ticket items relevant to the Enatai Interceptor: fish windows, park impacts, and lake level variation. Photographs of our favorite fish. And Enatai, during the summer, you can kind of see the kayaks. There's a rec center there. So it's heavily used. And the Ballard locks, which are operated by the Army Corps of Engineers and control the lake level. So that's about 2 feet higher in the summer than it is in the winter months. And that can have positive impacts and challenging impacts. Lower levels are less head behind containment areas, but also it reduces the draft or the depth of water in some of those shallow locations. So those are the factors that we've worked with. And in terms of schedule, what this means is for the project, we're going to start the day after Labor Day, minimize the impacts to the park, and also that's within the fish window. We'll install the containment areas in the last few weeks of the permitted fish window. That's through the end of September. And then that will allow us to conduct the work outside the fish window, inside the containment area, and complete the work around the end of the year. So I mean, hopefully that gives you a flavor of just some of the physical and the permitting challenges that have gone into delivering a successful design. And Kim, I'll pass over to you to look at some more of the technical details. Thanks.
All right, thanks, David. If you could go to the next slide. So as David was talking about, I'm looking specifically at this lake line and what the issue was in the portion that was lined and unlined. And prior to doing the design, the available information that we had was really from CCTV data. And so when we looked through the CCTV data, it was clear that there were obvious defects in the liner that existed in the pipe that was in front of the homes on Lake Washington. We could see buckling ridges and some holes cut into the liner, purposefully cut into the liner. However, I'll get to that in a minute, but we had no information on ovality and no information on the liner dimensions for any of the design parameters. So, but significantly, the liner looked to be in fairly good shape. If you go to the next slide. So here, I'm specifically talking now about that area that's kind of outlined in red there. So that is the portion of the pipeline that had been previously lined, the part in red. When it goes then from the red over to the orange and yellow, that area had not been previously lined, and that pipeline showed some significant degradation. So we have this area in red with all of the homes in front of it that I want to specifically talk about now. This had been previously lined with CIPP that had been hot water cure. David, if you go to the next slide. Okay, so I forgot there were pop-ups here. So the Enatai Beach Park is what David was talking to you about a moment ago. The beachfront homes, that's the area that I'm going to talk about first, and then I'll transition and talk about the area in Mercer Slough, which is the new CIPP lining. Next slide. Okay, so as you can see, I have outlined on here with some dots. There were maintenance holes and angle structures. Now, what was interesting about this is if you look to the left, you can see manhole 1A, which is right close to Enatai Beach Park. And it goes all the way across the front of those homes to manhole 4, or excuse me, maintenance hole 4. I will get used to that one day, I think, maybe. At any rate, the angle structures, some of them had some pretty severe angles, and the county elected to line that in one fell swoop. So about 1,000 feet of liner put in all together. However, at these angles, the angles were fairly severe, some of them, over 20 degrees. And so you had some pretty significant defects. So you had some wrinkling and buckling of the liner, but only in these angle structure portions. And in those angle structure portions, when they saw the wrinkling and the buckling, they elected to purposefully cut holes in the liner in order to relieve the stress on the liner. Now, as you can imagine, a liner that now has holes in it is not really a lined pipe, because we have these areas where there are places for water intrusion as well as corrosion potential in the angle structures themselves. If you could, next slide. So, we then decided to look and do an assessment of this existing liner. And again, at the very beginning, this was just a CCTV analysis that they had done, but they had done the entire line. Next slide. And here's a picture. We're now in the 27-inch pipeline that is along in front of the homes. And this is just a snapshot that I took from the CCTV video. But we're approaching an angle here, and you can see that the liner was in pretty good condition where we were not in the angles. Next slide. However, as we approach the angles, we would get buckling and fins or ribs on the left side that you can see here. And then on the right, you can see a hole that was cut into the liner, which is one of these holes, or a breach in the liner, that we had to consider. Were we going to reline this pipeline, or were we going to do something to fix the breach in the liner itself? Next slide. Here is a close-up of one of those holes, and one of the significant things is that with the hole, the angle structure themselves were now subjected to the hydrogen sulfide that would come through that line. So for degradation from the hydrogen sulfide. And so one of the thoughts was maybe we could repair around these angle structures or through the angle structures, so that we eliminated the hydrogen sulfide exposure of the angle structure itself, and then wouldn't have to replace the entire line or reline the entire line. Next slide. So we decided to do a multi-sensor inspection, which they call that MSI technology. And with that multi-sensor, you're looking at a variety of tools that you can look for the structural integrity of that hose pipe. So we were looking for the structural integrity of the hose, the ovality of the hose pipe, or in this case, the hose liner. And then the questions we were trying to answer is a liner removal required? Do we have to go in and remove that and reline it? Can we reline over it? Or what is the true condition of the existing liner? Next slide. So here are some of the results that we got back, and you can see it showed us what the liner looked like inside. We gave an idea of ovality and also breaches in the liner for where the holes were. But generally speaking, we saw that the liner was in very good condition, at least for what we could see, and that what we could see used with the multi-sensor technology. Next slide. So we got some really good dimensional information. We were looking to make sure that the liner itself had ovality that was, we wanted to stay less than 5% as the ASTM would recommend. We also saw that there was very low amounts of I&I. We were able to estimate the approximate depths of the debris in the pipeline when we were doing that. And we needed to know that because you have to clean the pipeline, and we wanted to give the bidders some kind of idea of what the extent of the cleaning would be. But we also found out through the multi-sensor that there was severe degradation of the unlined portion of the pipeline. They had lost over an inch of wall thickness in the concrete pipe. Obviously, you had exposed aggregate and such. But this also gave us concerns about the part that had been previously lined and leaving those angle structures to be exposed to hydrogen sulfide corrosion, as our concern was we could fix the lining, but then if the structure fails, you could have a bigger problem with the overall sewer. Next slide. So we have this information, we have the multi-sensors, we have the CCTV, but did we really know the liner condition? And what we were at this point thinking we might be able to get away with just fixing the holes that were at the angle structures. So we decided to go and actually test the lining that was there. There were two manhole locations maintenance hole locations that we entered into, maintenance hole 1 and maintenance hole 3, as we can point there. At each location, we took 4 samples, and those 4 samples were each cut into 8 strips. So we had 24 tests on the liner at each of the maintenance hole locations. And we were primarily looking to see the qualities of the liner after it had been in the line for a significant amount of time. Now, this is a really important feature. You know, liners, the first CIPP liner went in Europe in 1970, which happens to be the same year that I was born. So we talk about 100-year lives, but you know, we're just now at the 50-year life. We've only had CIPP in the ground for 50 years. And I can tell you, having looked at these test results and being the same age as CIPP, is that I think the CIPP is much less worse for the wear than I am, for sure. At any rate, next slide, David. So the first thing we looked at was the flexural modulus, and we took these test results and looked at the flexural modulus from the different samples and the different maintenance hole locations, as I've seen here. Now, the ASTM gives a minimum flexural modulus of 250,000. The minimum that we found was 291 at maintenance hole 1, and the minimum we found was 329 at maintenance hole 2. So we felt really good about the flexural modulus and how this particular liner had survived since installation. Next slide. Next, we looked at the flexural strength. And so this is the ASTM D790. Prescribes a minimum of 4,500 PSI. As you can see here, looking at the minimum values from the sample sections and also the averages, we were well above the 4,500 in the existing liner that already existed. If you took the minimum strength and flexural strength and flexural modulus that we got in all of the samplings, the minimums, and you then did the design with it as if you were doing a design at the time, you come up with a safety factor of about 1.8. If you did the average values, the safety factor in the design was above 2. So talking with the county, they felt good about just going in and looking at a repair. And it's not just, we did save a considerable amount of money on the lining cost itself for just the liner. However, it's much more than that because you're out in front of these homes. They're on the edge of Lake Washington, gorgeous, beautiful homes, and minimizing disruption was really important. So now we were trying to figure out, okay, what are we going to do with those holes? How are we going to fix them? What are we going to look at? Next slide. So, you know, based on the testing data, you can now see the area between maintenance hole 1A and 4 that we had the possibility that we could just use the existing liner. The pipeline beyond that was not previously lined obviously would require a new liner inside, but we were focusing on this portion of the alignment at that moment. Next slide. So when we looked at the maintenance holes, we thought, well, you know, what would be required? Okay, we need to repair the holes in the liner. But we also have access issues. And David was talking about, the containment of the water. Well, we were trying to look to see if we could enter into the pipe only at the maintenance hole locations. Would it be possible to get to the damaged sections of the angle structures just from the maintenance holes? They can then repair the liner damage, but you're also talking about confined space entry into a 27-inch pipe, which is quite small, as you can imagine. I wouldn't want to be in there. However, welders weld 24-inch pipes internally often. And so this is something that we knew was feasible, and talking with contractors about doing this, no one seemed to have a huge concern about having to work inside the 27-inch pipe, as they were used to doing such things. Keep in mind that we also had to do some bypass pumping here, and the bypass pumping David mentioned could be a very, very significant part of construction if we were to go in and do a brand new liner through this section. And our focus then was just sealing the pipe at the maintenance hole and angle structure locations from within the pipe, as I explained before. Next slide. So these angle structures, they were under the water. However, it was very shallow. And I point to angle structure 3 and 4 here in this picture. You could physically see them from the boat. So it wasn't like they're very, very deep. You could look down and actually see the top of the maintenance hole from within the boat that was, 2 to 3 feet deep. Next slide. Again, David showed something similar to this, but with these maintenance holes, the idea of going through a maintenance hole sounds terrific. However, many of these maintenance holes are underneath the docks. And so we'd physically have to go out, demolish the dock right above it, go into the maintenance hole, and then rebuild that dock, which was another whole area to look at because of different regulations about rebuilding docks and what kind of standard you have to build them to if you were to take them down in any way. Next. So we did come up with a scheme for the areas to repair, and this was an animation originally, but with our two of us doing slides here. On the left-hand side, we decided that it would be feasible to use maintenance hole 1A to repair the angle structures 3 and 4, and that's the yellow circle on the left. Maintenance hole 1 would then require entry just to seal the maintenance hole and rehabilitation itself, and they could also go from maintenance hole 1 down the pipeline to angle structure 5 for repair. We then didn't need any repairs between there and maintenance hole 2, as that area didn't have any bends in it and the liner was in great shape there. So maintenance hole 2 would go in and seal that maintenance hole. We could then also look at access at maintenance hole 3 to go back to angle structure 6 and up to angle structure 7, and then entry into maintenance hole 4 to go back to angle structure 8. So, a pretty complicated scheme, but generally going through 4 maintenance holes and going back in the pipeline to the area where there are bends in order to repair these holes. Next slide. Here is just a picture of when we were doing the testing of the liner, and you can see the maintenance hole is actually under the dock, so they had to lift the grate from the dock in order to get in there, but not exactly what you would call awesome access at all. Next slide. So what were the benefits of repairing these holes? There was an estimated savings of, $750,000 just in liner cost. We would save the construction of 4 to 6 of these in-water structures that David was talking about, which is no small issue in and of itself, especially since they were going to be opened up and stay open for a while. And then we could also minimize the amount of flow diversion, minimizing the time in front of the residents' homes on the lake. Next slide. So the additional benefits would be, shorter duration of barge work, schedule savings, the construction that's less dependent on regulatory restrictions. If you're going into an existing manhole and staying underground, you're not subject to fish windows and such. And it was a much less elaborate diversion scheme. Next slide. So what did we look at to fix here? A lot of people say, oh, what about, spot repair with the CIPP spot repair, which sounded like an okay thought at first. However, we're in a curved section that has defects. So you can imagine that sealing, going in and putting in a spot repair in a curved section that is rippled and has ridges we were really worried about how that would actually bind to the pipe and whether or not it would come loose. Next slide. We looked at a host of different CIPP spot repair methods, which there are many. However, we knew that it would mimic the defects, mimic the fins, mimic the bends, and although it would repair the current holes, it was really kind of overkill since these holes were literally baseball size holes. Next. And so one of the things that ended up in the specification was doing some polyurethane grouting. Polyurethane grouting is used to cut off groundwater in many, many construction applications, but it's expansive and it seals. And so one of the huge benefits of that is that it doesn't take a lot of equipment. You could see there's a polyurethane grout pump on the left. It is really small. You can see the drill there. You can also get it in tubes like you have caulking, and it expands massively. So for a small hole and a person who had to crawl through a 27-inch pipe, this seems like a really ideal solution. Next slide. So now I've talked about that previously lined section. Now I'm going to move over a little bit to the unlined section. With the unlined section, we looked at CIPP curing methods and decided not to allow an ambient cure strictly because of the lake temperatures that we have throughout the year and the possibility of not having a full cure on the pipeline. We also looked at thermosetting CIPP resins, and with that, they're activated by hot water and steam. However, with the water infiltration we were getting, we knew we were going to have to use a pre-liner there so that we could get it. And there were concerns by the regulatory agency about the hot water, the heat around the pipe, and how that would infect the fish in the near shore environment. Also with steam cure, there's the risk of it not having even temperatures over the full length of the pipe. So we were a bit concerned about that too. The other consideration though was UV light curing for the CIPP lining. And eventually we did end up specifying a UV cure. Go to the next page. So, with the steam cure and balancing these out, the big things that we were looking at with the steam cure, you have the styrene odor. You have difficulties with infiltration. Anywhere the infiltration is into the pipeline, which of course we have these holes, the temperature, it changes the temperature. The steam is not nearly as hot and you can have problems with cure. And so that inconsistency in the temperature was one of the things that we were very concerned about. Next slide. Looking at hot water cure, again, you have the styrene odor, which I think we can't underestimate the impact that would have being right next to the homes and in a very lucrative area, very beautiful area. The styrene odor, I think, would have had a major impact here. You can also have infiltration difficulties, but keeping the hot water at the right temperature and really cooking the liner with enough time we have the confidence that it's cooked was another thing that was concerned. Then if you use hot water, you've got to do something with it. There's water that you would have to dispose of in some ways, depending on the residents and how active they would be in this process. We've seen some areas where people don't want the water that cures the liner release because of styrene concerns. And so this was becoming more and more a big topic in the industry. Next slide. So the big advantage of UV cure was one, that there is no styrene odor because the styrene is encapsulated. So it does have styrene in it, but it's completely encapsulated. So there's no odor. It's also an impermeable liner. So you don't have to do a pre-liner, you pull it in, but it's impermeable on the outside. So the infiltration does not affect the resin or degrade the resin when you have infiltration. But the best quality of UV cure, or the thing that I like the most, is that you pull in the liner, you then inflate it, and you run the UV cure light sensing mechanism, or the light train that you see on the right side. It has a camera with it, and you run it down the pipe and back to make sure that your liner has fully expanded and is fully fitted prior to cooking it. So again, as it says UV cure, it is the light that sets it off, not the heat. Although it does get hot, it's very, very localized. And certainly I have put my hand on the outside of a pipe where it was being cured on the inside, and it's warm, but not hot, and certainly was not going to change the water temperature for the fish concerns. it's also, if you have an area that doesn't get cooked quite as well as you would like, you can run the train through it again and cook it again. And so there were so many advantages of the UV cure that we felt that it compelled to specify that UV cure would be used on this section. Next slide. The other concern that we had, or consideration that we had, was just the amount of equipment that you had to get to each of these locations. As you saw with David's slides, these were very constrained sites. We've got barges and platforms, and just looking, I'm not going to read through these lists, but just looking at the equipment that's required, whether you're going with hot water, steam, or UV, it was so much less equipment for the UV that really it lends itself to these very tight postage stamp sites. Next slide. So, you know, I've talked about these advantages, you know, the greater risk mitigation, you know, you can pre-cure, inspect, and make sure your pipeline is inflated properly. You don't have these cold spots that we talked about, and it's impermeable, so no resin washout. But what are the disadvantages? Not everything has, you know, an up and a downside. Everything has it. So the big one was cost. It is going to cost more to do a UV light cure than it would be to do a standard cure. However, when we were looking at this a few years ago, there were very few contractors in the Pacific Northwest who were doing this. Now there are many more, which has been a great evolution throughout the project, as we have talked to many of the local contractors now who are doing the UV cure. To give you an idea, the in situ form was not even doing UV cure at the time that we were looking at this technology, which they now are, as are some of the other really big contractors who are national and in the Pacific Northwest. Next slide. And so I'm handing it back to David now that I've explained about the rehabilitation portion of the project. David, back to you.
Sure. And really just to wrap up, before we take some questions or have some time for that. So just looking ahead, we are in the final stages of design and getting the last permits that are coming in and being incorporated into the contract documents. Due to go to bids or mid-year with contractor NTP the start of next year. And then this work, again, I mentioned that because of the flow diversions, this is the last element of work. And so it's scheduled for construction or implementation in the fall of 2024. So with that, thank you for listening. And we've got a little bit of time for questions. And Jennifer, you might have been picking some or getting ready to moderate. So.
Yeah, so I'll just remind everybody who's attending that there's a couple ways for you to, a couple ways for you to ask your questions. You can use the Q&A button that's on your screen to just type in your question and we can get to it there. Another option is that if you would like to ask your question in person, to raise your hand and I can open up your mic and your video if you would like, and you can ask your question that way. So far, it looks like we have one question from Raphael that was asking about the alignment. So it sounds like it was asking why was the alignment through the water chosen over an alignment on land, but that sounds like that might have been a little bit before your project's time. That choice.
Yeah. Well, certainly with the existing Enatai Interceptor, I mean, maybe what I'll say is, I suppose Lake Washington is one of those stories of success in that we couldn't swim in it 50 or 60 years ago, and Metro, that became King County WTD, put in these projects in the early 60s that collected the water and pumped it away for treatment rather than going straight into the lake. So amazingly successful. Now fast forward 50 years, well, environmental permitting is just different, it's tighter. And so be done.
Uh-oh, it looks like David froze there in the middle of his answer there.
If he is not going to come back, one thing I can tell you is we did look at an alignment, but when you look at the topography, those houses that are down on the lake, you go up at a pretty steep hill to the roadway above. And so when we looked at that, it was going to require grinder pumps for these homes, which were unbelievably unpopular with the homeowners in the area. And so it was felt that it was just unsurmountable to go in and say to all of these people, we're going to put grinder pumps in here and pump your sewage all the way up to the roadway and put it in there. It was preferable to rehabilitate the existing sewer in the existing location.
Great, thank you. I am not seeing other questions, so just reminding folks. You answered the questions that I had noted down, kind of about the availability of UV cure here in our area. And it sounds like a lot of the major contractors that we see for lining now do that. And then on the cost, I know you said that it is more expensive. Do you have kind of a little bit more about magnitude?
Yeah, when we looked at this section of the alignment, it is going to be pretty pricey, which is going to be about $300 a foot, which when you think about CIPP lining, that is fairly steep. However, when you looked at the alternative and the grinder pumps and the other ways to treat it and the other ways to handle it, it was going to be much more expensive to go in another direction. So we just got the cost question. I see David is back and asked about the cost for it. With the contractor question, you know, we're seeing that there will be 4 to 5 available contractors in the Seattle to Portland area type thing that we think that we've talked with that said they would be interested in this. And so, you know, when we were first looking at this, we knew of one that was local. And of course, that was an issue and problematic for King County because we're not going to sole source anything. And certainly we didn't have tens of thousands of feet, which would have pulled contractors from the East Coast. There's much more UV cure on the East Coast than there is on the West. And so, but luckily, as this technology has caught on and the benefits are there, and especially with the styrene issues that are going on in the public eye, a lot of the contractors on the West Coast have just picked it up and been going with it.
Thanks, Kim. So I'm not really familiar with the styrene issues. I mean, you talked about there being an odor, but I'm not, I mean, I think that in Eugene, we do more of the hot water or steam cure. So I haven't heard about that.
It's such a strong chemical smell, and there's been a lot of tests that show that the levels of styrene that come out of the maintenance holes is such that it will not cause physical damage. But I'll tell you what, when you smell it, you think, oh my word, I am breathing in toxic fumes. It's just very, this chemical smell, it's just not pleasant. And so although it has been deemed to be not harmful, the styrene issues in the public that I was talking about, there was a study that was done at a university, which was paid for by the competitors of the CIPP industry, that said that styrene just might be bad for you. And so there's been this huge discussion and debate, and the International Society for Trenchless Technology took on a large research project and evaluated what had been done at that university, as well as what the statistics were. And the city of Portland had been doing research on styrene with all of their jobs for years. And so there's a tremendous amount of data that was available. And the International Society for Trenchless Technology came forth and said it was not harmful, and pointed out who sponsored the studies and how they measured it, and they weren't ventilating properly, yada, yada. And so there's just been a tremendous amount of debate. And there are some cities right today in this country that'll say no styrene where we are, absolutely none. And so that debate has been going on now for a good couple of years. And there's, you know, there are many people who are very passionate about it on both sides.
All right.
Thanks.
So again, I don't see any other questions. So I guess, thank you for the presentation. For one thing, it's really interesting to see a project that's kind of outside our Oregon area and to hear how other people are tackling these problems. Just to remind the folks that are still on here, we have another kind of wastewater focused presentation in early May, and then followed by a couple that are a little bit outside of our traditional presentation mix. We have one that's going to be a little bit more operations focused, and then one on the homelessness issue and how one city is taking that on. So thank you again, David and Kim, for the presentation and for everybody who joined us today. And if there's not anything else, I'll let you all go back to your days. So thank you.
Thank you.
Thank you very much. Thanks, folks.